everybody. I'm Julie Klump. I'm going to go really fast because the important part is what these two want to present. So preservation of affordable housing, that's COA. We have 11,000 units in 11 states, every climate zone. So we deal with renovations and new construction. The exciting thing is we have tried Passive House, we've tried Net Zero, but we finally have a Passive House that not only received the Passive House grant, but is also signed up for the incentives through Mass Save. And this is what Ed from Delbrook is, thanks for coming out, Ed, and then Wes and Ken from Building Evolution Corp are going to talk about an exercise we felt like was the right thing to do. We always hire GCs for pre-construction services, whether we're doing Passive House or not, because we feel like that integration of pricing, constructability, sequencing is key to a successful project, especially when you're talking about overlaying Passive House. And what they're going to talk about is what's different about it. And the neat thing about this, and I don't know if this anecdote is going to come out, is that we brought in Delbrook, we talked about the project, and then when we said Passive House, the mechanicals went up $2 million when we got our next estimate. And then we had this meeting with Wes presenting this, and then the mechanicals went back down $2 million. So it's a classic example of getting this stuff in front of people because they have some important feedback and just talking through it. And I think right now this project is about 2% premium over a code compliant building. I know code's a little higher in Boston, but we're excited about starting it. And I know that everyone up here would say, let's just get started, but we're going to keep talking about it until we start. And so thanks to Wes and Ken from Building Evolution Corp, there are CPHC. We also do commissioning on top of that so that we can, anything missing from the CPHC or our radio verifier, we can make sure that we get the typical testing and overview that we usually get. So thanks, guys.
Yeah, thank you very much.
So, hello, thank you all for coming out. It's great to see a bunch of familiar faces. Those who I haven't met yet, I look forward to the opportunity. Where's Frank? Frank's back here somewhere. So there he is. So Frank and Nick have been hounding Wes and I for a good long time, Aaron too, to put on some kind of workshop about pricing Passive House. And they wore us down. So here we are. And I was really shocked when they told us we only had 4 hours to do this. We're going to pull it off. But at the level with you, Wes and I to cost estimating or pricing jobs. We do, we can tell you what's different about a Passive House, what goes into it, but we're really not your guys' pricing. But luckily, we brought along Ed Sopel from Delbrook, and Ed prices stuff kind of every day.
Every once in a while.
Every once in a while. And Julie, where'd you go now? Who pays for stuff. So between the two of them, they should give you a good idea of the incremental cost, and we'll tell you about what's different with the Passive House. We'll take it from here?
Yeah, sure.
All right. And a lot of you probably know this already. So our plan for today, does a Passive House cost different? And then we've got a fun little activity like we call more or less that will work with you guys. Have a little bit of time for perspectives pertinent to pricing Passive House, and then open it up for questions and discussions. That probably will finish up a little before midnight. So I understand. Go.
Traffic's easier then.
Yeah, it is. Yeah. Order pizza. I think there's about 3 dozen on the way. All right.
Push down.
Oh, down.
Yep.
Down is forward.
Down is forward.
Okay. Good. All right. How does a Passive House cost different? So how does it cost different? You can't answer that without answering the question, how is Passive House different? Different from what? And how long is a piece of string? So it depends a lot on what are we normally building. And we can tell you what's different. So what we'd like to do is go through, let's talk about what are the big things that are different in a Passive House. And I've written them down over there, but these are, the exterior wall and the insulation in the exterior wall. That's real different. Air barrier is different. Windows, floor over, whether it's over a garage or an overhang over ambient, that's going to be done different. On the system side, you get your heating's probably a little different. Your cooling, ventilation, dehumidification. Am I missing anything? Y'all are doing dehumidification, right? Your projects? Okay, good. Good, yeah. All right. Things we attach to buildings, like a parapet, canopy, balconies, added features, PV panels, sunshades. We've got some stories about those if we get time. And then, of course, the design process. Things are going to be a little different. And in the construction process, things are going to be different. So let's go through an example. We have the exterior wall. So what we normally do, right? We're going to put some kind of vapor retarder on the inside, maybe a smart one, maybe a dumb one. Cavity insulation, sheathing. Sometimes it's tape, sometimes it's not. An air and water barrier. It's going to be on the outside. It may be here. It may be a loose sheet. Exterior insulation. Typically, we see that between Z-girts. So, by the way, that's not continuous insulation, but it's exterior. We'll give you that. And cladding. So, what's different in a passive house? We're going to take an exterior wall. We're going to have no, typically, I know there's different ways of doing it. There's some people doing a double wall construction, but if we're putting the insulation to the outside of the sheeting, we no longer need to do anything more than latex paint on gypsum for a vapor retarder on the inside. So we get rid of that component. We have cavity insulation, we have sheathing with integral, two different ways of doing it. There's the zip wall approach, right, where we put up the sheathing, it's got the stuff on it already, you tape it. There's the fully adhered air and water barrier, real continuous insulation, so we're have to actually be continuous and cladding. So, just an example, over here on the right, we have a kind of a typical wall section where we might see some Z-girts going through there, vapor barriers to the inside, or vapor retarder in this case, and an alternative system giving us continuous installation, slight variation on the theme. Here's another system for continuous installation, and this is shown over an air and water barrier. The picture of it. Okay, so here's the part of the program where we're going to introduce you to this game of more or less. All right, so what we're going to do, we've talked about this wall assembly. We'll give you a chance to review it. We're going to ask you, the audience, to tell us whether the passive house building is going to cost more or less than what we normally do. I'm going to need a tally map. Is that you, Wes?
I think it's me.
It's going to be a tally map. All right,
Great
Wes is
announcing.
going to take a tally. And then we are going to submit your answers to Judge Ed, right, from Delbrook, who's going to tell you if you're right or not. And if you get enough answers right, we'll come up with a prize later. Trust me, it'll be worth it. Fantastic. All right, so again, here's in this example what we normally do in the passive house wall. All right, so is the exterior wall more or less? All right, how many folks are going to tell us that the passive house wall assembly is going to cost more than what we normally do? All right. Okay, what kind of a number do we have?
Oh, now they're going up more.
Is there more?
There's more now.
All right,
Let's say there's 2 4s.
just to make up a number.
Like 17 or 18.
Yeah, okay. 19. Good.
There we go.
And how about less? All right, we got a 1, we got 2, we got 3.
3.
All right, so we got 10.
4.
All right, I'm going to round it up. Okay. Yeah, you could say the same, or, the correct answer is always it depends. So we're going to just disqualify that answer altogether because that's just too easy. And you can say it depends, and you're going to explain to us why it might be more, why it might be less.
So just to Julie's point, we were fortunate enough to win the RFP back in the day and get introduced to, you know, pre-construction services. And for us, I was back in the days when LEED was brand new and everybody got super excited. And, you know, I'm going to speak today about process because, you know, every job is a little bit different. And where we look at that is your baseline budget could be a little bit different on every job. So, you know, talking about what you're going to pull Mattapan a lot, you know, and the 2% difference and the high numbers back down to low numbers. So for us, you know, the exterior wall on Poa Mattapan was, you know, a little bit more. To Julie's point, it was a lot more at the beginning, and we were talking about Cascadia clips and night wall system, and just like LEED, you know, we brought Ken in and Wes in, and we did a subcontractor kind of kickoff, and I brought the 8 or 9 or 10 envelope, you know, subcontractors in, and we went through the details, the presentation, and I can only just go back to the same thing with LEED. You know, you get the subs that know the systems, they get comfortable with the systems, you go over the pros and cons of each system, and over time they get more comfortable. And, you know, so far the numbers have come down. It's definitely more because you got thicker insulation on the outside, but it's your girt system versus your night wall system. And, you know, the night wall system has some thermal, you know, bridging in it that allows it to not, you know, have to have the Cascadia clip. Again, you wouldn't know that until you go through it and learn it and look at the details, but the exterior wall is different. Our base budget already had some, you know, stretch code in it, some, you know, City of Boston, you know, LEED silver certifiable stuff already in it. So the delta wasn't as much, but it's definitely more overall. But again, I think it's going to be the same thing over time when more and more subcontractors and vendors get more price competitive, people get more comfortable with it. You're going to see sub numbers coming down. You're going to see more people doing it, getting more comfortable, and then that conservatism and, you know, fluff factor is going to, you know, over time come down more. But right now we haven't built one yet, so this is all, you know, estimating pre-construction, and we feel comfortable if the budget's right, but it's definitely more than a normal system.
Okay. So, you guys are good.
Off to a good
So
start.
good. All right. Down is forward. Air barriers. Something very different about Passive House is the air barrier. So, what do we normally do? I think, you know, are we typically doing? It seems to be when we look around here, what's going on? It's a lot of fluid applied. In the stick rope world, where it's not non-combustible, we see tape sheathing with the integral air and water barrier. Oops. And so in a Passive House, it's kind of the same materials. We probably see a little bit more of this kind of stuff. You probably hear sheet membrane. Is Oliver here tonight? Oliver? All right. But we may see some unfamiliar imported products.
Cost of the actual material.
The whole system, the whole time. Are we still doing? Really? Okay. All right.
It's okay.
Okay. All right. So maybe there's some things that are different. Certainly the level of application is hugely different, right? That's the air tightness there, 0.06 CFM at 50 pascals per square foot of enclosure. Will be a test later. You can compare it to the compartment compartmentalization of 0.3. So that's factor 5, if I get the math right. And I'm referring to that number there as PS 2018 standard. And of course the compartmentalization is Energy Star as well. So it's like code, only tighter. Sorry about that. A lot tighter. So I don't know if folks are using this portion of the code, and maybe the numbers have changed from 2015. So it's kind of been in there, a performance path for air tightness in the code. So that's what's in the code. It's about 0.3. So again, Passive House is about factor 5 tighter. Another thing that we run into with Passive House is sometimes the air barrier is on the inside. It's not just around the outside of the building. You may have a space that is inside the building, but we want to say it really should be separated from the rest of the program, like a compact room would be a good example. So we're needing to bring an air barrier to the inside of the building and figure out, you know, places like, oh, I can probably shoot that here, right, where where we're gonna need to probably turn the air barrier in, and things get out of sequence because you're doing your exterior application there and then coming back to frame in that wall. Those are things that happen. Okay. Ready for a second one? You can keep this going. All right, so the air barrier system versus normal. Is this more or less? You see the more first.
Wow, okay, fill the entire room. Yeah,
Are you looping in compartmentalization?
This is just the exterior overall building air barrier.
who says less? Okay,
All right,
2 say less.
2 less. Okay. Judge Ed, what do you think? What do you think? 29?
Sure.
Yeah, it's a good number.
So this is one of the, I think, challenges that we're looking forward to learning, and it's one of those kind of not things you can estimate. It's the same material, it's the same products, it's the, everybody's obviously super focused on waterproofing your facade, so that's not going to change. The cladding's not going to change. This is where, and you'll get into it, you'll see some more details later on, it's the interruption of the material that presents challenges in Passive House. Example would be, there'll be a detail later about the roof parapet. You need to continuously carry that air vapor barrier and waterproofing barrier. So that means that has to go on as you do your roof sheathing, and then you're going to put the parapet on top. So not something we normally do. So it's the kind of indirect cost that you're going to have to, the resequencing, and that's another thing we're fortunate enough with pre-construction. We've gone to numerous meetings. These guys, with TAT have done document review through SD to DD to permitting to, so there's meetings weekly, every other week, just going over details. And that's what we're fortunate enough to, we have my superintendent and my project manager on those calls, working with the architect, working with Ken too. That's where the unknown cost, the uncertainty cost is going to be. So it's like, it's more, but it's not a budget killer. It's not going to be something that, it's going to be more supervision, more sequencing. And I think over time, again, the more and more of these buildings we build, the more and more it's going to become commonplace for architects and us as general contractors and CM. So it's not that big a deal. The material, the subs didn't give us increased costs. They're comfortable at this point through 2 or 3 rounds. To Julie's point early on, it was a catastrophe with 4 or 5 times the number, and how am I going to do this? And is the product different, to a point where now we're comfortable that they're comfortable with scheduling and sequencing. So it's really that hitting cost that, unfortunately, once we build one, and we'll get a little bit more direct cost database, but it's very, it is more, but it's not a budget killer.
Okay. So we'll give it to him?
Yeah, we'll give it to him.
All right. Good. And Ed mentioned the architect, so I want to give a shout out to Brad Griffin there in the back row.
Hey, Brad.
All right. Great work on this project. We'll talk about process a bit later. Windows. They could afford wood windows on this project. Take this picture on the way over. All right. What we normally do is something like an Energy Star qualified window. It's probably actually a little better than Energy Star. We have, because usually we're needing to do exterior insulation control. We have these bucks, we're projecting the window out, trim extensions, kind of a little bit of fussy details around windows. In a Passive House, better window. You could spend more on a lesser window performance-wise, and what criteria you're looking at, but better in terms of the U value and having not only the glass but also the frame becomes real important. The way the window is installed in a Passive House is typically right in plane with the sheathing, and the air and water barrier makes things a lot simpler. This is what I would tell you to do anyway. Thank you, Passive House, for giving me the leverage. And looking at windows with integral trim extensions. So let me show you what we're talking about, what I mean. How we typically do it might look something like this, right? Lots of lumber, because we have these bucks, the window is projected out of the bucks, thermal bridge right there. So can we do something about that? Can we set the window back to line it better up with the thermal control of the wall? Can we do anything to get insulation near the window frame itself? And also in terms of the air and water control, you get this fussy detail with the bucket. And we could draw these things, and maybe we can believe you can bend in the membrane at a right angle. But I know this has bunch of outside corners. And they get to be a thing of origami, and I would say from my experience, fluid applied is not the solution. Maybe on a couple windows, but not on several hundred windows on a job. So I find that approach a little bit risky. So here is a passive house approach. Right? We've got this nice window with a frame extender, integral trim extender in it. And look where we can put the window. We just nail it on the sheathing, right? Like we always do. Right, so yeah, it's right in there. It's black and white. Should have colored it up. And then it makes the air and water transitions really simple. And so I was trying to sell you on this is a little simpler approach, risk management, but how does that come across in cost? You still have this window that's probably going to be a fancier window in terms of price. So let me start with the less. Who thinks this passive house is going to cost less than? All right, we got one. We got two.
Who's going to the highest bidder? 3, 4.
All right, and I'm not even going to look. More.
Oh, about 25.
25. 25.
One
So
with a
the
double
window
hatch.
package goes higher. Ed, what do you say?
So this item is a little different. If you do it in a vacuum, your windows absolutely cost more. Your Alpine window is a superior window. It costs more, absolutely. You have to do the net balance. You have to do the adds and the deducts. You got to take the cost of the framing. You got to take the simplicity of the waterproofing. The integral detail with the window trim to the cladding material is proving to be very beneficial to our subs and the architect and the waterproofing consultant. So you're already paying for the insulation. So to deal with that 3-4 inches of insulation, most of your cladding materials get kind of expensive if you can't deal with that, an EGR or brick return or all your other cladding materials. You start doing big window returns, that's when your cost comes up. Integral window returns is very beneficial. So for us, it's been almost a wash, if not, as crazy as it sounds, it's been a little bit less on the framing and window bucks. So you just gotta, again, for us, we used the normal everyday window manufacturers. The lesson for us is, the Julie and Poe's experience, in DC and other projects, they educated us. And, I had never even used Alpine window before. So again, you'll hear that a lot tonight about process, and we've learned a ton where we went in with the normal materials that we use every day, the normal manufacturers, and you really need to get educated. You need to be comfortable with the process. And once you go through that, we have 3 or 4 now, manufacturers that can compete with the triple glaze. They all do triple glaze differently. They all have different extensions. And for us now, we have new window guys. If we didn't have those, yeah, it would be up the same thing. It's more. But overall, it's been a net wash for us. So far. So,
What about the tape and inside now?
with respect to the waterproofing piece,
The install.
the install piece, we haven't done a mock-up yet, but that's right now the framer and the waterproofing guy. I'm concerned with that. They've come to a couple meetings and they're comfortable that they're actually looking forward to not having those outside corners and dealing with that. Again, it's going to become a sequencing issue. Most jobs now, you do the window frame first, and then you got to put the buck on, then you got to do the water ABB again. So from a sequencing perspective, this might be able to get our windows in a little bit quicker. Fins, no fins is also something you got to look at with your waterproofing. So
A really crucial thing, it completely changes the aesthetic of the building as well, because of the way you visualize the windows, because it makes sense now. I mean, actually,
returns.
they look much more like a residential building.
It tells you a bit about how the building is built. So it reveals something. Thank you for that. All right. So we're ready for this. How are we doing so far? You holding up okay? You all right? All right. I'd like to talk about an overhanging floor and the edge condition, because this is just about everything that I see coming in is a podium construction. So we're going to be dealing with this sort of edge of a floor that's hanging out over either a garage or ambient space, something unconditioned. Right? So that's going to present a challenge. So what we normally do is we're going to sort of build some sort of ceiling and enclosure. We're going to stuff some fibrous stuff sitting on top of that, put lots of holes in it. Yeah?
I'm just gonna say less.
Less. Yeah. All right. So in a passive house, we don't do that. Right. just a little illustration of what I mean by this is what typically see. The wall passing right by the slab edge coming down. We might have a tile ceiling across the field, lots of leaks in the joints there. We're gonna stick in some lights and other fixtures and get some more leaks. And, you know, we have a gap here. I mean, yeah, it's fire stock, but it's not really tested, right, to be airtight there typically. And then the floor is cold and we have to pump heat in there to keep people from complaining. So that is kind of what we see as the standard practice, been going on for a while. Here's another approach. Sorry if I keep shooting a laser, you guys. I just missed the button.
Laser.
You guys have safety glasses? Put them on. That'd be great. All right. So typically, if we have conditioned space above, we can carry the air and water barrier down past the slab and wrap it in. In this case, using some closed cell to really block off. We wouldn't call it fire smoke stopping here, but it's easier swimming around the perimeter. Another way, and hats off again to TAT for coming up with this. So simple, but introduces a sequence issue, right? Because then Ed's guys have to come back and build this infill, everything that's going in underneath the podium there. But then when we can come back, finish the sheathing, finish our water control per usual. That's it's hidden slides. I figure we don't have time for tonight to talk about the field of the floor, but it's another slide. We can get to that if we have time. All right, so back to this one here. Okay, how many people are going to tell me that the passive house system costs more? Yeah.
1, 2, 3, 4.
I'm sure it does. Really?
Okay.
Okay, how about less? Yeah.
About 10.
How many people really don't want to tread on this one?
We got more than 14.
So a passive house podium would have like, a 30 in the floor.
Okay, so I didn't have the details. Want to bring it up?
We can
Can we
unhide it.
Well, how about, can we
We'll
get
go
back
back
to
to it.
John at the end?
Well, what floor are we talking about? Over 80?
That's the commercial space.
Well,
Podium over commercial.
Commercial,
This is-
first floor.
in this case, it happened to have conditions.
So it's adiabatic.
Right, so it's adiabatic in this case. Similar condition though, but we'd add insulation if it's over,
No, I get
over
it.
it, right?
But that's the cost factor, right? Adiabatic doesn't cost anything.
Okay.
If it's over a podium.
We still have the air control, right? Because in this case, we're separating a non-passive house program from the passive house program. So we've got residential over commercial, so we still want to have air control. And we still want to have air control anyway for compartmentalization and for managing the building pressures. So this is one thing that's really, this just reveals how passive house is kind of good risk management, and good practice. So it's making our job easier to have the weight around the banner of passive house to get some good performance. So people are kind of ambivalent here. You have some questions?
Put some actual dollar numbers associated with the cost.
Four.
This is a little vague, more or less what?
Yeah. How long is a piece of string? How big is your building? How many square feet? How many linear feet? Yeah, so just trying to get you here. I mean, it's a valid question, right? What is the number? We really don't know until we have somebody bidding on the job. So what we're hoping we can do tonight is, give folks here an idea of how to position their projects so that they can minimize that increment, or at least understand what fuels the increment, right? And understand through that what kind of questions to ask, where to push their GC a bit, and then we'll talk a bit also, about process and how we bring the GC in and how we can really have a good informed discussion that I think helps with pricing quite a bit.
We started out, Julie was nice enough to say 2 million. It was 3, 4, 5 million. It was a crazy amount of money, and we never would have got down to where we are. Again, that's why I kind of had that disclaimer. It's all about your baseline budget. So we had enough in there to deal with typical, Energy Star. We had, Stretch Code. We had that stuff in there. We haven't built it yet. We haven't bought it out yet, but we have bid it 3 times. We're comfortable. We have 3 or 4 bids across the table. So Julie's 2% is not off base. It's right on. What's not in that 2% is, a little bit of supervision and a little bit of oversight. And, we'll get into, I don't know how much we're going to get into this mock-ups. You're going to do a lot more mock-ups. You're going to do a lot more in the field. We have to appoint, a passive house person in the field. So that's an assistant super, it's a superintendent full-time to overseeing that type of stuff. But the numbers are real. I just get nervous giving numbers because it's all related to a baseline budget. I could just be comfortable with the process. It's helped us out tremendously with subs, and it's vague, but it's real.
I just want to add to, sorry to interrupt, is that what we promised Delbrook and all the subs was that we're not going to toss drawings over the fence and say, build us the pass house, that we're planning on extra diagnostics, we're planning on extra reviews, we're planning on extra meetings to talk about the details that someone's trying to build in 3 dimensions and it's not working for the drawings, so that we can stay ahead of those details and get it right. But that may be an extra cost for a while until we get the market up to speed, but that's something I think is key, because there are typical diagnostics and oversight that you can provide, but then I think the subs UPC deserve a little bit more attention on the time of these budgets.
And John, I apologize, it was a little vague. I was talking about, in this case, Flora over Mediabatic. Some of the lessons I think we're going to bring forward. All right.
That one's more of a TBD. Again, it's almost like the roof parapet issue. It's more of a sequencing thing. And this detail gets a lot easier when you get comfortable with the night wall system. You'll see that they have corner clips, then screws that allow that detail to work with the sheathing and insulation. It's really clean detail when you want to make that 90 degrees. So the resequencing is an issue, but it's definitely buildable both ways. Both of those details can be built successfully, but so that night wall system.
So what's your verdict there?
I think it's still a little bit of a TBD.
TBD. All right. It's TBD. Well, I think you're with most of our TV audience was in about the same place. We didn't have many people jumping in. Okay. Let's talk about that parapet. We don't have anybody emotional here.
How about those guys that got electric?
There was a pool right below me. Okay, so what makes a passive house different? What we normally do, right, because we're trying to brace that parapet, so we take advantage of the cantilever of the framing, run straight up past the roof deck. The roof membrane goes up and over. The AWB of the wall runs up to usually the parapet cap. Maybe they come together, maybe not. So in a passive house, we don't do that. And I'll show you a bit why. In a passive house, we would have the air and water barrier wrapped directly onto the roof deck from the wall, and the parapet gets built on top. And it looks like this. No, actually, it doesn't look like this. This is what we don't do. And I just want to help explain a little bit of what one of my old boss, Joe Steeper, could call parapetitis. This is just something that happens, right? Because this is fluffy stuff in steel stud walls, so that's kind of open, and this sort of that beam serves to unify everything in one big pressure plane. So we get air going up there, and it will leak out and kind of condense and get icicles coming out from under the cap. You also have issues with condensation because the backside of that thing is real cold. There's no insulation on that side, and you have interior air mixing up and circulating there. So you expect some condensation back there. And then you also have issues with continuous insulation and a lack thereof. So that is our typical kind of parapet condition. So here's how we want to do things different. Right, we want to be able to put that wall sheathing on, the roof sheathing, make a nice, simple 90-degree corner, right, and do a continuous thing. Only doing that continuous thing, that's probably pretty far out of sequence, and that's a bit of a stretch. what we could do to make life easier is, all right, when the framers are there, put a membrane strip there, make that connection. Framers continue on, frame up the parapet, and then we can run the AWB up the parapet and the air control on the other side. Okay, and we've isolated the parapet, taking care of a major air leakage location. So, doing okay? All right, you're gonna get back with me now. You kind of dropped off on that last one. Let's start with the mores on this one. Is the passive house approach gonna cost more? Stop and
6,
start.
7,
I don't know, it's not
8.
many. It's not many.
about 8, 9.
Oh, I see 10.
All right.
All right. Okay. Call that Wes. How about?
How
on
about
the other
less?
side?
Okay. 1, 2, 3, 4, 5, 6.
That's a cop out.
It's about 12, 14.
12, 14. All
or
right.
less.
All right. I'm gonna say.
Okay.
Put it up there. There's somebody in the hall with a hand up.
All right.
So, what do you think, Ed?
It's incrementally more. You,
Yeah.
you need to add the strip, you need to spend the labor. It's not definitely not less, but it's going to be a sequencing thing. It could be a lot more if you don't plan and you don't anticipate it, don't know the detail, but it's definitely a little incrementally more.
Incremental. All right. What do you think, Wes? Do we have time for one more of the enclosure? We're going to switch over to the.
What time we got now? 7:15. Time we finishing? 10, 11? Time we finishing? 10 or 11?
All right. I think I want to hand it over to you on the mechanical
Okay.
side, and if we have time, we'll come
What do we
back.
have left? It's just canopy, right?
Canopy.
Canopy.
All right.
Wait a minute.
All right. Canopy. Normally, we got to support these, right? Because they have to stay up and pull down.
Rule number 1.
Thank you, Wes.
Okay.
Building has to stand up.
That's right.
Okay, so what we normally do is we're going to have a piece of steel. It's going to run right through the sheathing. We're going to try to make it airtight by stuffing some stuff around there and put a bunch of cookie in the web space and try to cover that up. Make it real. And then passive house, well, not that. We do something different. Structural thermal break maybe. And this, we might look for ways to simplify the air and water barrier. Okay, so for example, thank you, Brad. It's beautiful. But also, just a little segue here. Some little credit to TAT because they approached us with their structural engineer. We want to do it this way. And Brad says, well, we should run it by Building Evolution to see what they say. And, you know, I said, I think you better tell your engineer to do it again. And of course, Brad being the architect, he's very diplomatic, so he brought those words in a more gentle term. And the engineer came back with a thermal break here. So great, we have a thermal break, and sure, it's not insulation, but man, is that better than steel? It does a lot less. But what I really like about it, the science geek in me says, I can flash this piece a lot easier. Flashing to a square thing. We know how to do that. I'm pretty sure that can be done in the field. So that's one thing that's going to be different for these little attachments, little roofs and canopies sticking out. You know, we're not going to have steel sticking to the field. All right. Let's get another picture from their website. So, what do we say? Is this going to be more? Who says more? All right. Line them up. What do you got, Wes?
About 15, 18.
15, 18.
Who says less?
How can that cost less?
Sure? You gonna say less?
Volume
1, 2?
engineering is going to eliminate.
All right. Oh, we got a couple less in there.
About 5.
All right.
Okay.
It is more, but it's 1 or 2 on a job. Once you, I think it's the Amatherm blocks we're going to be using. So it's a structural block that, again, education for us. We have a new manufacturer that makes blocks that can, again, thermal bridging is the key. The continuity of the barrier is key. That doesn't get accomplished with steel and wood ledgers. So it's definitely more, but again, the grand scheme of things on $45 to $50 million job, a couple canopies and a couple armor therms boxes.
Okay. Oh, dear God. You know I'm good at breaking things.
You like your ribs.
Oh, yeah, I just broke 6 ribs 2 months ago. It was good fun doing it though.
Would you do it again?
Yeah, I've got a 4-wheeler since.
All right.
So here we are getting some heating systems, and we're going to look at some, traditional, same idea, traditional versus getting into what we might do for some passive buildings. So, hold on here. So what would you do here? In traditional, the boilers have a hydronic system to connect the entire building, controls, fan core units, or baseboard radiators, or you might do one-to-one heat pumps or VRF. The best options that are common for new buildings today. What would be different for a passive house? Probably wouldn't be boilers. You keep it to the VRF or one-to-one heat pumps. They're both fairly common types of technology that are widespread and used in many different types of building. And there's, Ken, do you want to do the building?
It's the electric slide. Anyone?
No? No. So, what can be improved on a situation like this? If we're going to go one-to-one systems, what can be improved?
Solar panels.
So, okay, solar panels.
Yeah.
Yeah. So, how about not doing one-to-ones? I mean, look at that roof. You can't really do much with it. You can't have a ping pong or anything like that on that roof afterwards. You can't do the harder to solar panels unless you do a canopy up over it. The other thing is, if you were to go VRF for that building, you're looking at a central system located somewhere on that roof, nice and tiny, freeing up the rest of the roof space. And think of what the roofer has to go through to try to seal up all those penetrations. You have 50 or 100 or 150 penetrations trying to get down to the actual building. And then you have all of these home run distribution systems going from rooftop to 5 to 6 stories down below to actually make the system that can work for each system. This is a headache for a roofer. So if we were to go from passive house versus normal, what would you think would cost more? If you were to go from a typical building versus a passive house approach to say VRF type system.
And what's the typical building? What are we putting in typical? Is that boiler system?
Yeah, because the boiler, the loads are small.
The loads are smaller.
Yeah.
So now that's why we did the enclosure first, because the enclosure system has brought down the loads. Yes, now if we bring down the loads a lot more, then the systems are smaller, less equipment, and especially if you go from one-to-one heat pumps and get you onto VRF, your distribution systems are actually separate themselves. So if you were to go to, let's say, looking at a standard boiler system of one-to-one and now getting to a VRF system for a passive house, what costs more? Anybody say more? Less? A lot of less.
All right.
All right, Ed?
So it is less on Polo Mattapan, with a little bit of a disclaimer. We need to get more subcontractors in the market. We need to get more manufacturers comfortable with this process, with the multi, in this region hasn't done it for a long time. You don't have a lot of buildings that have tested this over time. There still comes with winter issues of snow and stuff like that. But, we do it in assisted living. We do it non-passive house. We're doing a ton of VRF. We have multi-unit buildings in Brookline now and other areas where we're doing VRF. So it's more and more manufacturers, Mitsubishi, LG, the more players you get in. But again, it's a subcontractor-based issue for us. You have guys that do it. You got to get them more comfortable because their experience with it has been, warranty issues over time that they've got a ton of callbacks, with the valves and maintenance companies not shoveling the snow. And there are other, cons to a VRF system, but it's worked out on Polo Mattapan that subcontractors. We've got 3 or 4. They went through that education process too. And then obviously you get the savings, with all the penetrations and all the other stuff and all the coordination through the building. So it's worked out on Polo Mattapan. Less, we do have buildings that, other buildings are building now with VRF cost more than your traditional aquatherm and boiler-based buildings. So again, it's not really a passive house thing. It's more of a industry VRF versus an aquatherm boiler trade-off. But there's a lot of benefits to it.
And on that hand, we actually need the PV, in order to meet our, source energy. And so for us to do 1-to-1 for 135 units, it might be a real trade-off. And apparently there's legislation potentially in place so that if you had a VRF, if you had some market rate units and you wanted to build them, or you wanted to build all the residents for heating, cooling, electric costs, there's potentially going to be an avenue for that. So opening up the route with the VRF is always our choice, just in order to allow space for the portable space.
One quick, well, two actually quick things. There's the legislation that Julie's referring to. There's actually a hearing next week if you're interested in seeing sub-metering allowed in Massachusetts for VRFs, you can build back. There's something introduced, it has problems with it, but if you want to weigh in, talk to anybody at Passive House Mass and we'll get you information. The second thing I think is operationally maintenance. If you go 1-to-1, there's a lot of indoor filters that you have to change a lot of times, right? And the more central you go, the less you have to go in and bother time.
So we should clarify that this VRF system still has distributed air handlers.
Okay.
Every apartment has an air handler. What's different is that the outdoor units are consolidated and the refrigerant lines through the building are consolidated to branch boxes. So there's less copper, less coring, less holes. But still, you still have the maintenance issues on the inside, a lot less on the outside.
But you have one air handling unit per units.
Yeah.
And you wouldn't have like really supposed to walls with each room or something like that. So that, if you're going that approach.
Unless the size is more appropriate, right?
Correct. So now you can actually get down to the lower loads. Because it suits, you get one VRF that can take on both units and get down to the lower loads possible. As required. Versus trying to take an oversized one unit. Which is not kind of short sighted.
Usually the smaller 1-to-1s can go down much lower than a VRF. Because of the 1-to-1 has the ability to come way down where you go to the multi. The low setting on the multi is going to be always higher. But it's much cheaper.
Well, if you have a VRF and you share the load between 20 units, that part load between those 20 units is when it's going to be able to grab down, store down to their loads. Versus if you're on this one units, it gets harder to get down to part loads. Only a partial done. It's hard to get down to some of these low down pumps that we were required. Yes, because you're pushing out over multiple units. So
You get a higher CM level and you get a higher HS one to 1-to-1. Because you have that ability to size that 1-to-1 and capture the unit.
Well, there's also the benefit too of the shared heating and cooling, right?
heat recovery out of
Heat
them.
recovery.
And the larger systems also go down to lower outdoor temperatures, so a lot of rates will get over the systems heat required, which is good for both parts. Whereas the smaller systems, when they get down to 0 degrees, you start to switch over to electric systems. And the larger systems might be -30, -7 degrees before you can switch over. Still, you probably put in maybe like 60% of the loads at that temperature, whereas the 1-to-1 works. So, that's another advantage.
And are the refrigerants environmentally safe
Yes.
now?
Better, but getting there.
Yeah, I mean, this is like CO2 would be carbon dioxide. Still haven't figured out how to make that safe for people.
What
But,
about CSCs?
so at 410A, what the systems are now.
It's such a refrigerant for all.
It's not currently safe, it's not safe for the environment.
Yeah.
And the industry is looking at transition on a 5 years at most for a different refrigerant. Because this refrigerant is not right. It gets released to the atmosphere.
Any requirements, yeah. So they're always
Then
paying
it will
well.
last.
Yeah.
It's still down. So improvements needed, moving that way.
So incremental steps, I think is the. Yes.
Drill down for this week. What we're currently looking at is refrigerant leakage rates equivalent versus the equivalent of doing other electric systems. Carbon that equivalence of that leakage, so it's, you know, possibly just like the arc system.
The thing for us is that we always want to, like, we're not required, but before the law, it doesn't require it. Nobody's required not to do it. But we need to. And so if we do, if it's a new building, we want to put in boilers or hydronic, then we're either adding two extra pipes in the chiller, or we're trying to use two pipe systems and convert it. And the cost of running those pipes, and even maintaining those pipes and condensation, we've priced that several times, even on rehab, and it just keeps coming back to the maintenance and installation of that system is more expensive. So we keep leaning on the VRF. I think we're all, we all agree. We might have some data on people. We have a lot of specific data on VRF that we installed that we've been concerned about that. But, yeah.
All the time, and whenever we're trying to build commercial products for gear up and maybe specifications that I think refrigerant helps like hundred kilograms.
And we have to plan for our operating costs for our sites, we have to say maintenance costs and, refreshing the system. So we have to, yeah, we had some of that. It's not awful, it's not, something that doesn't change our mind about it, but,
It's a little scary.
yeah. No, you don't want a lot of that, but, it's less than that.
Andy, do you have a thought on that? This is,
Andy Hoshman. As I think Hank put it best, like refrigerants are not the perfect solution, but in time are getting better. And yes, it is a viable concern when you think about the total carbon cost of your building, the refrigerant leakage and the recharge that will contribute to global warming. And just another part of the equation.
Mike Dupuy just brought up a good question. You, Peterson Engineering, worked on valency on a Taunton project. Was that was water cooled, basically radiant cooling. Right. That was not VRF. No. That was in the apartment building. In the townhouses, it was all, not VRF, we actually one. Yeah, for example. Here the water heat pump. Both heating and cooling together.
you able to pick up drive on one code? Yeah. We haven't done this in residential, but we've done it in the, what we call it, municipality buildings, and there's a lot of these functions. Do it. All you want to do is from scratch, because localized, so you can really not replacing, drawing the ground. The pricing is definitely still higher than the drawing distribution, and something like 4 types of 2 types of things. Yeah, like it is I think it is a problem. Your story about when we start the systems up in the week, and then it's hundreds of pounds of energy.
Well, we at least like the PRS system or a heat pump system before they started up, they have to go through the rigorous pressure testing on the system. So it should get and we'll have to bring up these all out. We should work with them.
Well, that's true. These massive 100-unit buildings that are loaded with tons of refrigerants, that's a lot of opportunities for
Yeah, maybe one-to-ones or POS are all refrigerant based, and if you have the air to water, there's no refrigerant on that side. You want to have sanitary steam and food, you put pumps in everybody's spaces, and you're just trying to solve the problem. Right on.
It just don't happen, because we don't want to be where we are. We want to be in the southern Mediterranean, we're not. So, you know, that's why we have these problems.
Then here we have an example C for, I just want to see if everybody's paying attention to numbering schemes here. I wanted to check out, but cooling systems, and use this as an example of, here's one example of refrigerants leaking. Well, here's a 1960s chiller that leaks refrigerant wind blade. It's like you have to get them basically black market. And if you look at if you look here, kind of good, no good, almost good, and very good. That's the four compressors on it. So this is a project where we're ripping that out and putting it new right now.
Not a whole project.
It is not a whole project. No, it is not a whole project. Nope. But what's the difference between the passive house and normal? Well, we don't do any cooling inside a normal building, or maybe you just do a window AC. That's not necessarily a really good, useful solution. You have your chillers and fan coil units, like that discussion we've just been going around about doing a 2-pipe, 4-pipe system, providing cold chilled water to the building. You do a 1-to-1 heat pump or a VRF. What do you do in a passive house? Very good. It's already paid for by the heating. So your cooling system is already paid for. There's no added cost. Less. Wow. Who said more? Anybody?
Can we just take a gimme on this one?
Okay.
What do you think, Anthony?
Yes, that is accurate. Yes.
All right.
All right. So the heating was less, and the cooling was definitely less. Don't need to go through this. Now we're back in the numbering because everybody's paying attention. Ventilation systems. What do we do normally? Well, might exhaust from the bathrooms, maybe supplies, corridors, might rooftop ERPs, ducted rain sheds, these halls. What do we do different? We put in ERPs for supply to the actual bedrooms. The questions are, is it centralized, individual, semi-centralized? Now, these are all design considerations and going through the design phases of the project. So to take you through, this is part of what we did working with Peterson and Mattapan, is what do we do with building like this? And if you look at the centralized system, so you got an ERP, where do we usually put it? On the roof. There's a lot of space up there. Not if you always one-to-one pumps, space. But now you need to put a lot of large gas supply up to the actual roof. You have a lot of large ducts coming down from the rooftop down to the building. They all need to be fire rated and being spaced within the building in order to connect it. That's taking up programming space. And when you try to balance the system, how many buildings get balanced properly? Always. Julie's answering that.
You mean after they're built?
After the built, yes. Before the built, the balance fine. So then we don't do this once. We do it 2, maybe 3, maybe 4 times over again on the building, right? And then it's kind of work, right? Well, how does it look internally? Then we have a big supply and return duct system. As it runs down through the entire building, it gets bigger and bigger and bigger as it gets close to that central vertical route out to the ERP. And same sort of issues, larger ducts with higher temperatures trying to balance this large system. And the ERP is connecting that floor here to other floors as well. So it comes with a larger heartache.
If it goes down.
If it goes down. If it goes up, it's okay.
Thanks.
Okay, so then the horizontal supply and return, well, you can do balanced supply. We're exhausting somewhere of the unit, typically the bathroom, and we're supplying somewhere to a living space.
And are we doing this typically? I would think of this as fairly advanced, but do we have people, are we direct supplying the apartments?
That's cool.
Good. Thanks.
And then exhausting the kitchen ranges out of the building. And depending on where we're located, we might actually directly ventilate the supply air to all the administrative bedrooms. How many projects are doing this? Whether it's passive house or not,
Yeah.
depending on who's interpreting it, and then where it's building's located too. But yeah,
Okay.
we've seen it interpreted different ways, so just checking. So that's code, and if you're interpreting that way, pretty straightforward, right? So then, if you look at a semi-decentralized, here's an example. This is work that Peterson always came up with on this project was, what if we ditched the roof documents? What if we actually found locations for smaller systems on the floor? And instead of having these big honking, ductwork systems running down the hallways and trying to find spaces for that, feeding all the other mechanicals and electrical and plumbing on the ceiling spaces. What if we just did smaller ducting? But now they're supplying exhausting smaller stuff. Right? So simpler supply and exhaust. Less penetration, so through the building each floor. Here's the system that we actually use for this project, and with this, they're able to pick a coil that works off the DRF system. So it's a cylindrical zone, and it's able to regulate the discharge air temperature, and also control some of the supply air.
So you're not using gas.
So yes, this is just 100% ERP, just air.
That's teamed up with the jiu-jitsu.
Exactly what they're very well.
That's one of the options, but for this project, it's a Mitsubishi for it, yeah.
And you said smaller ductwork, is that small enough to be integrated into flooring or ceiling as in part of the building's office?
They're up in the truss spaces. And the key for that, the smaller ducts, with penetration of that corridor wall, it becomes a fire rating issue. So small ducts are much easier to manage when you penetrate in those walls.
And the unit itself is Plenum mounted, the things down above the ceiling.
And then the passive house in unit ducting.
It sounds like the same as.
It's pretty similar. When you're supplying to the bedrooms to living space, you're exhausting out. You got the kitchen now is tied into it, but it's a general area exhaust with a filter versus going out to the wall and having the penetration to the wall or vertical shaft or kitchen exhaust.
So that's probably the difference we end up with.
Yeah. So just a recap here, we went decentralized, and what do we think? Is it more? Yeah, a little bit probably.
Yeah, those are all passive house certified air handlers too, right? So.
Yeah, we would, in this case, this is a FIAS project, so it's not, doesn't require it to be a certified piece of equipment.
No, but they are.
They're high efficiency equipment, yes. So it's not
So
a,
they're a little more sophisticated. They're more.
yes,
So
absolutely.
the equipment size, they're probably in the.
Yeah.
How many say less? 3 about 5 say less. Yeah, I'm sure.
How many are asleep?
Congratulations.
If you're not here, raise your hand. Where are we? We get a few yes.
Ventilation, we got a few yeses.
This passive house demolition is different than
Okay.
What do you think? You're about 20 or so on the more side?
If they're asleep, they're saying it's more.
I'm not looking. All right. What do you say, Ed?
Early on, it was definitely more. It was, again, education. Subs were not familiar with the units. We had a little bit of a spec issue that we corrected. Ultimately, with the horizontal stuff, it was, again, that's why I preferenced it at Mattapan. It was a savings. We had 3 bids that were lower. Again, but the net savings, you got to get all the fire dampers, the floor holes. So it's a lot of other things other than just taking an HVAC number. So it definitely saved money for Mattapan. We were definitely in the doubter category. We had big increases up. We were 7 figures increase at the beginning to almost definitely a savings. It was a wash on the HVAC and then all the other savings with shafts and ductwork and drywall and closet spaces and all that stuff went away with that horizontal, and then penetrating those outside walls become a lot easier when you're dealing with 3 and 4 inch ducts, not 6, 8, and inch ducts. So it's saving money on pole Mattapan.
All right. Right on. Oh, we got 2 questions.
Yeah, maybe also, is there a DMV about the DMV review?
Listen, so just so you know, the DND review required us to increase that when job pricing skip and under. And so we were able to model that and make that work. But we feel like there's judgment on that, which is really reasonable. We all want to shop at that because they were looking at projects that had leaky ducts or not continuous with some inefficient radio exhaust evaporators. And then that CFM that would come with that house will work fine. We haven't, I don't know if this is something they understand, but that's the only critique they have is how come we don't have enough exhaust like that.
The only other thing too is AeroSeal. Get to know that company. It's definitely going to be needed. You can go the traditional way and you'll start feeling your duct leakage tests. So it's in the number. So we were able to absorb that in that net savings number. We're going to be doing AeroSeal on these ducts. So it's just, again, this testing requirement.
And I think that's a really good point. If Michelle was here, she would probably weigh in on it. That's a pension from Cambridge. They tested the first 4 ducts and it was just flawless. So they were like, oh, maybe we won't test the rest of the ducts. So they built the next, they were like, oh, let's just test it. And it was a disaster. So they ended up testing all of them. We have a project that's not even passed on that the subjects are having a hard time hitting the duct leakage, minimums that they're supposed to hit. And so Peterson, and they're now sort of requiring that, which takes a little bit off the sub in terms of hitting the air tightness and maybe it's peace of mind for an owner. It would be nice to know if somebody could hit that, but I know, they just need hands. And so to hit that level of air tightness, and then it is a cost that we're part of the cost.
Scott, you had a question?
Wondering, another D&D question. How did you deal with not exhausting the kitchen range of the exterior?
Because we have the exhaust from the kitchen, they're at the moment fine.
Is there a research on the hood or nothing?
There is a research. There's a 4-inch research.
It's continuous range.
Here.
That's a change for that.
Oh, yeah.
Cost question. I was just curious how much your cost was impacted by the tie-in to VRF and to your comment earlier about the learning curve and changing of the industry from the sub.
Yeah, they were big swings. I mean, we had a lot of dialogue and a lot of conversations. Julie was pushing because they weren't seeing this in other areas of the country that they were building. So we were in the millions. And when we had to have that meeting with 4 or 5 HVAC contractors, they came in, they got comfortable with it, and we priced it, and it went way down.
It's going through a lot of change.
It is, and again, more manufacturers get more competitive, and then for us, we do a lot of units, thousands and thousands of units, and getting the manpower available that want to do these type of systems, versus hydronic systems, versus we have subcontractors that only like aquatherms. They want to do the individual aquatherms. That's what they do well. To get them to be comfortable with the VRF. And again, the biggest hurdle for our guys is warranty and getting comfortable that the VRF is going to work in this region, because I think there's still some doubt long term from a subcontractor, not from engineers and building owners, but there's definitely still that unknown from the subcontractors. It's going to be okay 20, 30, 40 years down the line with that extreme temperatures that we used to see, we don't see now.
Thank you.
Yeah.
Humidification. This has been a topic that we're not getting enough time here. I know. This is a topic by itself. So maybe another day.
It's really cool.
I know. Design process. You want to take this one?
All right.
I
I was actually gonna ask you this.
So everybody talks about integrated design, and there's it's very descriptive. Interesting communities has one, mine is Red, maybe Ruby has one, but that's something we probably not think about too much, but, the integration is like, it just makes so much sense. Where your architects, they have enough to think about in terms of meeting code and life safety. And then we're gonna layer on all those enclosure details. And then you have a mechanical engineer or Pearson, but there's very few that get it and how to design a low load when you commit to them building any kind of enclosure. The density table, and we've had so many meetings with PAT. We have a huge test call project in DC, and it's just constant review by our TPHC and our verifier in order to as we move the drawings through SD and BD and CD, everybody's looked at the enclosure. The DC is on board, he's pricing that, reaching out to subs, what is thinking about this, and it's sort of like integrated design without calling it that. So if that's what everyone's experience is integrated design, then that's exactly what everyone should be doing. But if not, this is how it should roll.
Okay, so, I'd be afraid to contradict Julie there. But anybody else want to weigh in on whether the design process under passive house scenario, is going to be, we need to budget more for this, or is it going to be the same, not the same, less? More or less.
I think we need to budget more, but the premise is to remove extra costs. So it's just moving the money.
It's like commissioning, right? They put something about 18 months. So, I mean, look at the things that, like, if we just told Delbert we were doing test house, and they were kind of going at this in the dark, like, what does that mean now? And so we have to demystifying this. Maybe 5-10 years, there won't be so much demystification that we have to do, but they deserve it, and our architects deserve what our goals are and how to achieve it. And so I think we're never going to move the market on this unless we really spend the time to pay attention during design, have everybody at the table, pay attention during construction, offer any support anybody needs, try different products, and until we get it, and it seems like, oh, okay, well, this is what we did, but maybe a little different, or this is what we did. It's a lot different, but it's still the same. It's the same trade, it's the same scope of work. It's a little bit more, careful.
Where we at? I think, yeah, we're gonna let you talk about the construction process and wrap up. We'll hit on it briefly, construction process. There's lots of stuff, right? We're doing mock-ups, we're doing additional supervision. You mentioned maybe the other day, you're gonna have extra personnel on site specifically for passive house jobs.
Yes, the muscle.
You get sequencing issues, where you got trades that are gonna be going up in lift, and then they have to go away, have lunch, come back later.
So it's just really what Julie talked about. We do it, most pre-construction, our most successful jobs, are the kind of the same process, whether it's passive house or not passive house. But, we're fortunate enough, my superintendent was gonna be building the building, my project manager was gonna be building, my executive who's gonna be running the pre-construction and buying out the subcontractors has been at all these meetings. And, having a superintendent give his kind of feedback to TAT, to these guys, to Peterson, and that for us is gonna be predictable now. We feel a lot more comfortable that when we go out and build this, there's going to absolutely be this aggravation. If you look at it negatively, yeah, you can be, oh my God, we have to do this, this, and this. But Ken did a great job of scaring us in the very, very beginning. about all this stuff, but again, we've been getting more educated and more educated and more educated. So if we didn't go through that design process with TAT and everybody and the consultants and on those calls, it's absolutely more money for us, but it's going to pay off in the end.
Yeah, and like, Michelle Keating is doing, the bin in Cambridge, but she explained to me that they have our meetings for every weekly meeting. If there are any, like, health details that are coming up, they spend time looking for this, as opposed to this two-dimensional sheet of paper. Like, what does it look like for you? Like, can I get installation in between those two pieces of wood that you want me to? Can I really do, sculpture with this membrane? And that's made a big difference for them.
And for us, I mean, it's more of an investment cost. Like I mentioned before, we're very fortunate to be living this, large job, multi-family job. We're going to learn a lot, and cost up front is going to pay off for us. We're going to be ahead of the curve. We feel like we're ahead of the curve, as a construction manager, and we thank Kohler all the time for that opportunity and the education we're getting. We're doing internal training. We're going to get all our people. We have 3 estimators here tonight. We're all in. That's where this business is going. So that's, we're very fortunate for this. We're going to obviously build one and tweak our opinion of certain things and deal with it. And again, it's for us, it's predictability. And if you're ahead of the curve, whether you're ordering materials or planning, you have to be ahead of the curve with this testing stuff. And I think a lot of it's a lot of noise, and it will become part of normal processes. And the subs will get comfortable. We'll get comfortable, and I think over time it's going to be a different goals.
Okay. Functional mock-up, not just for aesthetics, we're gonna build a box and test it, make sure the details work. Testing systems along the way, air barriers and such, windows, trash chutes, various things that present problems. Take advantage of the verifiers out there. They have the gear, they have the fog machines. Test along the way. So we already covered this.
Okay.
Right? Definitely, it says it's definitely more of the work. All right, so you guys did okay. Yeah, it's all right. Yeah, so there's, I think this shows that there's some mixed perception, so we hope we were able to get you have a better understanding of how the costs come in. Perspectives. You look at this screen here, you get, that looks like a pirate. Arr. But you look at Isaiah over there, he's a regular building science. So it's really a lot about perspective. Thanks for coming, Isaiah. Good to have you here.
I should have warned you, Isaiah.
It's the one.
So, Ed, I wanted to turn it over to you if you had any lessons learned or perspectives you wanted to share. You
kind of summarized it all as we went. For us, it's just you just gotta acknowledge the teamwork, be comfortable with it. For us, it's going to be a market share that we know we're going to be ahead of the curve, and whether it's TAT, whether it's Kohler, whether it's Ken and Wes, and just get involved, be open-minded, don't be closed-minded. And for us, we think we're ready to go. We're gonna start in the spring, and we look forward to it. And everybody's talking about it. DHCD's all over it. It's going to be a funding thing, and they're going to put a ton of money in it, and we're going to build a bunch of buildings.
We're planning some tours, so that during the order test or like certain increments, when we can say, all right, everybody get on our hat and look at how we screwed this up or how we got this right. Because we're in it to move the market, and Massachusetts, I think, is a little bit far ahead in terms of incentivizing this, but the more we can learn here, the more we can learn the sources that we do.
And I'll say, relative to the, I think it's about the costing in a way. The process that really was great. I got to credit the team here, like TAP, and welcoming us and inviting us in to talk about details and putting up with my snarky attitude. Brad's a very patient man, so I appreciate that. So it was really a collaborative process. And then
you know, once Delbrook got on board, you know, we had Luke Grady in there, we're going through, I had a list of, what was it, like 114 details that we had to go through the big log.
We're down to 8.
Was it?
Now we're down to 8.
You down to 8, right? And a lot of that is, well, we knocked them halfway down when we met at their offices, but then Luke Brady came in, your super, and he would say, what are you trying to do? You know, he can say, all right, well, if that's what you're trying to do, and it was really, you know, it was the builder, the architect, and the pain in the ass, all working together to get, you know, come up with the details and get it right, so that when you go to price this, it's understood what you're doing, and it's not only the lines that are understood, it's the intention as well, and the process is there. So that's what I thought was, you know, that was a real takeaway for me about how to control the pricing on a passive house job.
Where do you think you are relative to national counties? Now, when you add it all up, where do you think you are?
I think we're doing good.
Like,
I think we're doing pretty good. This is, given that, you know, I think Delbrook has taken on a lot of risk, and, you know, if they were more risk averse, the number might be higher, but they've been very amenable to jumping in, and that's good. I think
But I think we all feel comfortable with it. But nobody on this, well, Delbrook and Cole, we haven't done this yet. So,
you're not done.
you know, so
What kind of a
The thing is, we're looking at the sidewalk meets the wall because there's such a grade change. And you know, like the details that we have, 114 details that Ken suggested, like it's not nothing from all the things we evaluated and worked with Delbrook on the sequence of how that enclosure's gonna go in, how that sidewalk's gonna be there, how do you protect it, and all those things. So I'm comfortable on the 35. Well,
We've flipped it, it wasn't GMP, and we've flipped it to lump sum, so we're comfortable. You know, we're all in on a lump sum basis. There's no GMP with a 2.5%, 5% contingency. Yeah, we have a little bit of allowances in the air sealing, and we have some allowances in vapor barrier, you know, in the drywall number, in the framing number. We feel like we're protected and comfortable enough now that the number that we're giving POA with sub coverage across the board is a lump sum.
in a year, we'll come back and say, yeah, great.
That's awesome. Yeah, 2% now.
Do we have, we finished a couple hours early.
So we do presentation number 2 now.
Oh, yeah. All right, the next one. So do we have, anybody else have some questions or discussion, or I guess you could pin us down if folks need to leave? You got 2 minutes.
So what you end up with for the night wall system for your exterior attachment? I kind of heard a couple different things.
The night wall is what's going to be done. It's in the sub number versus your traditional, maybe a Cascade or clip system or, you know, girth system, but it's going to work well with the Hardy. There's some, you just got to pay attention to dimensions and screwing patterns and stuff like that. But the night wall has vertical and horizontal. So the vertical is typical, you know, it has thermal breaks in it, and then you use the horizontal based on your cladding system. So that's what's in the drawing. That's what we're going to build in the number that we've given to POA.
Is it Fred?
Just go back to some of the stuff that I may have missed, is who everybody is. Building up a corporation is an estimator. You're an estimator?
We're Evolution Corporation.
Congratulations.
Precisely not. Sorry. Yeah. We don't do the estimating, which is why we have Ed Sokol here with Delbrook and Julie, who's the owner, who's they're right.
Where they are our CPHC. They're our CPHC.
Certified Passive House Consultant, commissioning agent,
They're our commissioning agent.
technical advocate.
Delbrook is the GC.
Yes.
Okay. Is there an owner's rep involved?
Yes. The owner's here.
What is this waypoint as well?
You're the owner and the rep. Good deal.
busy.
Okay, let's try to figure out role players.
Would you come in at, so what's the cost per square foot for construction plus site?
We can bring that.
The building's 49 million for 135 units.
It's crazy, so we're not really for what.
135 units.
We're dropping like 13 or 15 feet on the site. We've got
We have MBTA issues to deal with, and there's a whole.
I'm sorry, just because I was late to come in. Is this the old Cody site, or right by the MBTA station?
It's the existing MBTA Green Line parking lot, the end of the line where Papagino's and River Street is. The existing MBTA parking lot. The bus loop that stays in the whole time.
Aaron, you wanna?
Yeah. Just thank you guys. Thank you to Ed and and Kat and Wes and Julie. This was fantastic. Thank you guys.